What happens when your main router fails? Your entire network goes down. Even if you have a backup, most devices can't switch gateways automatically. But what if I told you there's a way to make your network 100% fault tolerant? In this video, I'll reveal how HSRP creates a virtual gateway so your network never goes offline. Want bulletproof redundancy? Let's dive in. When a PC wants to communicate with another PC, but is not part of its own network, then it will send the packets to its default gateway. On a redundant topology, IoE with two routers, well, it doesn't necessarily guarantee availability. In this example, routers 1 and 2 are responsible for routing to reach the top PC. If the router on the left fails, well, the router on the right will take over. The problem is that any termination device, whether PCs, servers, or printers, can only be configured with one gateway by default. That is, if router 1 is turned off, the bottom PC will be unable to send packets outside of its local network. This means that it will be isolated from the rest of the network, even if there is a redundant router, which could serve as the default gateway to reach the top PC. End-of-line devices cannot dynamically determine a new default gateway. The solution to this problem is technology FHRP as the next hop redundancy protocol. It is a protocol that allows gateway redundancy by default. It can be seen as a virtual router with a layer 3 IP address and a layer 2 MAC address, which will be shared between two or more physical routers. The bottom PC will therefore have to configure the IP address of the virtual router as the default gateway. And that way, when he wants to communicate with someone from another network, well, he will use the ARP protocol to know the MAC address of his default gateway, which will be that of the virtual router. All packets sent to the virtual router's MAC address can reach their destination via any physical router. The physical router that will actually transmit the packet is completely transparent to the PC. Cisco routers and switches typically use 3 types of FHRP, all of which allow the default gateway to fail over seamlessly to the hosts. There are HSRP, VRRP, and GLBP. And here's a table that shows the differences between these default gateway redundancy types. We will now see plus in detail how the Cisco proprietary protocol, HSRP, it is based on a model of active passive. The router in active mode will carry the IP address and the MAC virtual address, and the router Cs in passive mode will keep informed of the health status of the active router through messages such as hello, sent in multicast. The active router election is done using the parameter of the priority. Each router has a priority, which can be changed by a network admin. The default priority is set to 100, and it ranges from 0 to 255. The router with the highest priority will be in active mode, and in the event of a tie, the selection will be made on the router with the highest IP address. If routers in passive mode no longer receive active router hello packets, then they will re-elect the active. For example, router 1 has a priority of 100, and router 2 has a priority set to 50. It will therefore be router 1 that will be elected and active in production. IP packets will therefore pass through it to reach the top PC. If router A fails, then it will no longer send hello messages, which are usually sent every 3 seconds. Router 2 will become active, and the packets will pass through it to reach the top PC. If router 1 is back in service, it will not have a new election. That is, it will only resume its role in the event of a failure of router 2